Hi all, and welcome to day 11 of Advent of Elixir. Today's topic is protocols and JSON encoders. I think it's something that a lot of you may have run into, so let's see how to deal with it. So, suppose you have a struct, in this case the admin module, and you would like to JSON encode it. Well, that's not going to exactly work in a straightforward fashion. Let's see what happens when we try to do that. So here I've written a show function, and it's going to attempt to encode the value, and then take the result and run io.puts on it. So, for example, let's do advent.show, and let's just do some sort of normal map. And you can see we get the JSON encoded representation out of it. But what happens if I try to do an advent struct? Well, we're going to get this big red error. And let's take a look at this big red error. It says the JSON encoder protocol is not implemented for advent of type advent. The JSON encoder protocol must always be explicitly implemented. So we're going to go through each of these options later, but let's take a quick look at understanding what that exactly means. So in order to perform encoding of values into JSON, what the JSON library does is it creates an encoder protocol, and we talked about protocols in a previous video. What that means is that it will treat each different type of Elixir term and multiple dispatch based on the type of the term. And importantly, structs, even though they are maps in strict sense, in the Elixir protocol system, they're treated as a different type than just map. And each different type of struct is treated as a different type as well. Okay, so the dead simplest way we can do this is to follow the second set of instructions, which is to derive JSON.encoder. So let's go ahead and write this, and remember this has to come before the def struct. Oops, derive JSON.encoder. And let's recompile and attempt to rerun this function. And we see that now it does exactly what we expect. It takes the foo value and takes the nil value that's in there and turns it into null and puts that inside of a JSON object. And of course, if we do foo with some actual value, then we see it encodes correctly. If we want to take a look at this first one, it says derive JSON encoder only, and then you're supposed to put some fields in there. So for demonstration purposes, this is what the equivalent one would look like. And then let's run this again, and now it works. But suppose you have this JSON your struct will talk to a system where it needs to re-encode this as something different, where maybe the key doesn't happen to be the same in the encoded form as it is in the actual struct itself. So how do we deal with that? Well, what we have to do in this case is to actually implement our own JSON encoder for the advent type. So let's take a look at what that looks like. Here I'm going to copy-paste some code that I've written, and basically what we're going to do is we're going to create an implementation for JSON encoder. That requires that we implement this encode function that takes the value that we're going to encode and an opaque options term. And we should be passing that into different encoders that will encode another value. So in this case, we just want to encode the map because we know this is going to still be a map. In this case, I want to say, let's suppose that we had some sort of weird foo-value key that the foo needed to be converted into. And we're just going to pull the foo value from our past value, and then we're going to pass the options in directly. Okay, so let's see what happens if we try this. And now we get the re-encoded JSON with foo value as it was. If we want to do something wild too, that's not out of the question, what we can simply do is just encode, say, something wild. Now this is actually not valid JSON, but it will still output that value in there. So we might want to do some work to try and actually format this as correct JSON, maybe like something like this. But it's certainly possible to craft your own JSON manually without taking advantage of the JSON encode functions. The other place where I think that this is likely to come up that is a very useful pattern to do is in the case when you have an ecto schema. So here I've got an advent.schema, and it may not be obvious to especially people who are new to Elixir and ecto that the ecto schema will create a struct that corresponds to this schema. So let's see what happens if we do this. Here it gives us a slightly more useful error, where it tells us that, again, we need to implement JSON.encoder here. So and in particular, you can see that the schema itself contains some interesting fields, meta, for example, ID, and foo. We may not necessarily want this meta field here. So let's go ahead and derive or recompile it and see what happens. And you can see here we get the ID and the foo fields taken. If we only wanted to encode the foo field, that is also certainly possible. If we attempt to do the first type of derive with only the module name of the protocol that we're deriving, we'll get a pretty useful error where it says that it can't encode metadata from the __ meta field for advent.schema to JSON. It's used internally by ecto and should never be exposed externally. So that's kind of an interesting message that we wound up getting. I believe that JSON itself is aware that ecto schemas tend to have these __ meta fields, and that it should provide this sort of a runtime error along the way. Of course, it's also completely possible to write your own implementation of JSON.encoder using the impl or defimpl keyword, as we did for Advent. But I just wanted to give you a quick how-to on how to do the 3 basic ways of implementing JSON encoders. Derive, of course, this keyword works for things that aren't JSON encoder. It works just as well for other types of structs, and will punt to the equivalent map that way. Okay, I hope you found that to be useful, and I will see you tomorrow.